Anti-gravity propulsion. The greatest obstacle to anti-gravity propulsion is the incredible amount of energy required to bend the fabric of space and time. But given recent advancements in quantum technology, however, it might be less difficult than we think. The Tic Tac UAP and other vessels filmed by the U.S. military appear to rely on a frictionless form of gravity manipulation. Theoretical physicists explain the UAP phenomena as a bending of the space-time fabric where you contract the space behind the craft and expand it in front. Again, the greatest hurdle is the immense amount of energy you would need to produce a gravitational field that could nullify the Earth's g-force. Something equivalent to a rotating Bose-Einstein quantum ferrofluid contained by a quantum metamaterial hull and superconductor may be a good way for explaining this incredible propulsion system. Two advancements in materials science and particle physics include the Bose-Einstein quantum ferrofluid and quantum metamaterial. Both of these scientific achievements involve manipulating the temperature or shape of something until an exact quantum effect is achieved. That is also why I refer to them as quantum technology. The first one, a rotating Bose-Einstein quantum ferrofluid, is what happens when you cool ions down in a quantum vacuum and then spin them around a superconductor. You can also do this with subatomic particles like the photon. In our case, however, all of the ionized atoms entangle their alignment in the direction of magnetized spin, producing a frictionless spiral. This is a form of macroscopic quantum entanglement. In other words, there is something about an empty cold vacuum, where atoms nearly cease to vibrate, that enhances the collective synchronization of ions, an energized form of atom that radiates electromagnetic energy. The idea being that a large enough frictionless spiral of Bose-Einstein condensate could produce an immense amount of energy. Let's not forget that the connection between superconductivity and gravitomagnetic field generation is pretty well documented, as is the frictionless quality of Bose-Einstein condensate. The best running candidate for an unconventional form of superconducting material that can spin, contain, and possibly even direct that incredible amount of electromagnetic energy is called a quantum metamaterial, which is what Luis Elizondo, a former Pentagon official, claims to have found at a UAP crash site in the form of a magnesium-zinc bismuth composite. Metamaterials are designed from the atomic level up. They involve meticulously positioning each atom into perfect alignment. Scientists experiment to find these exact configurations, but once they do, such as the 1.1 degree tilt between two layers of hexagonal, monoatomic graphene, the matter itself begins to behave very differently, as if you've unlocked a new ability. The unique ability of a quantum metamaterial is that it can manipulate electromagnetic radiation in ways that were previously considered impossible, utilizing the rule set of quantum mechanics. That could range from bending light, think cloaking, to storing it very tightly and in complex ways, which begins to blur the line between quantum metamaterial and quantum computer. The bottom line? The unconventional superconducting abilities of quantum metamaterial are well known to the scientific community and might be exactly what we need to control the incredible amount of electromagnetic energy generated by a frictionless spiral of rotating Bose-Einstein quantum ferrofluid. You could imagine an outer torus-shaped containment chamber made out of a different kind of quantum metamaterial than the superconducting core, obviously something more tailored toward containment. For example, quantum electrodynamic graphene metamaterial is known for its battery-like quality. Then, because a quantum metamaterial can also be programmed like a supercomputer, you might be able to encode the engine chamber and hull of the ship to coordinate for the purposes of steering. If it is just a matter of reducing superconductivity in one region and increasing it in another, that has already been achieved with quantum metamaterial. On top of that, because synthetic quantum materials are capable of bending light, it is not hard to imagine how cloaking would be possible as well.
Dude, this is a fucking drone, bro. There's a whole fleet of them. Look on the SA.
Jacksonville, Florida.